Hello class, this is the third example in how to prove a complex trigonometric identity is true using the basic ones you've learned about in previous lessons. Let's begin. All right, so in this case, we want to prove that sine r is equal to 1 minus cosine squared r divided by 1 plus sine r. So I've already gone ahead and provided the chart, and the first step is the fact that this is the given identity. And now we want to make the right side look like the left side. So let's start with this cosine squared r. We know from the Pythagorean identity that sine squared r plus cosine squared r is equal to 1. So if I subtract sine squared from both sides, we know that cosine squared r is equal to 1 minus sine squared r. So sine of r is equal to, I'm going to rewrite the cosine squared r as 1 minus sine squared r divided by 1 plus sine r. And that was a Pythagorean identity. Okay, now what? Well, 1 minus sine squared r is a difference of two squares. So I can factor that as the following. I can factor that as 1 minus sine r times 1 plus sine r. And what's the explanation for this step? Factoring a squared minus b squared into a minus b, a plus b. Next, notice that there is a factor of 1 plus sine in the numerator and a factor of 1 plus sine in the denominator. So I'm going to divide those two like terms to get 1. And the explanation there, divide like factors. So now we have sine r is equal to 1 minus 1 plus sine r. And what I did there was I distributed the negative 1. So sine r is equal to 0 plus sine r. So now we finish with sine of r is equal to sine of r. And now since the right side and the left side look identical, we are done.